So in the seawater it is being zero. Density of the seawater is 1.03, and the density of the ice also they have provided. The approximate percentage of the total volume of the iceberg above the sea level he is asking. So that means the one or the volume of the ice which is outside this particular thing. So this shaded portion he is asking that too in terms of the percentage. So since it's been balancing, so downward force is going to be balanced by the mg, and since it is in the seawater, buoyancy force will be applied by your seawater. So that will be in the upward direction since for the balancing condition. Mg, that is mass of this one, should be equal to the buoyancy force which is acting in the upward direction under the equilibrium condition. So from here, mass can be written as an volume into density of the ice into G is equal to volume inside into density of the seawater into G. These are the information which is given. Now, if I cancel these two things, so let V be the total volume and the density of the ice has been given as a 0.92, and that is equal to the. Let the volume inside is going to be okay V in into density of the water, seawater 1.03. Let me substitute this one. So from this one, we can write the volume inside by total volume. Volume inside by total volume should be equal to the 0.92 by 1.03, or I can write it as an 92 by 103. So since he has asked for the percentage in the volume, so I'll going for the percentage of volume submerged in water, submerged in water. So that should be equal to how much? Whatever we have got, this one, that is 92 by 103. 92 by 103 into this is going to be the 100. This is a fractional thing basically. So this comes out to be somewhere around. So it is 92 and this is 103 just above this one. This is 9200 by 103. So obviously it will be the 8 and somewhere around. So nearly I'm going for this one as a 89%. So from this one, so percentage of total volume of iceberg above sea level is equal to out of 100% minus 89%, which should be equal to the 11%. So our answer should be nearly around 11%. Okay, so this should be our answer. So single answer question type. Next one. Young's modulus of the brass and the steel are being given. Okay, Young's modulus of the brass is equal to 10 into 10 to the power of 10. And Young's modulus of the steel he has given 2 into 10 to the power of 11. This I'll write for the 20 into 10 to the power of 10 for our convenience. It is Newton per meter square and Newton per meter square. So now what is happening? A brass wire and a steel wire of same length, that is the initial lengths are going to be the same, are extended by 1 mm under the same force. So force is same and elongation of the brass is equal to the elongation of steel. This is the information given. Forces are same or the initial length of the brass is equal to initial length. He is asking the radius is going to be how much. Now when we go for the relation, that is Young's modulus, y is equal to FL by AE. From this one, elongation can be written as an FL by area into Young's modulus. Since in the question given that elongation of the brass is equal to elongation of the steel, from this one we can write FL by area of the brass into Young's modulus of the brass is equal to force into L by area of the steel into Young's modulus of the steel. So since the force and initial lengths are same, you can remove them. From this one, area of the brass into Young's modulus of the brass should be equal to the area of the steel into Young's modulus of the steel. Now area can be written as an pi into RB square into YB is equal to pi into RS square into YS. So if I remove the pi value here from this condition, so radius of the brass whole square into, so radius of the brass is 10 into 10 power 10, then this is 20 into 10 power 10. This is 10 into 10 to the power of 10, which is equal to the radius of the steel square into 20 into 10 to the power of 10. These two terms will go for the 2 times. From this one, radius of the brass is equal to root 2 times the radius of the steel. This is the answer we have got. So RB is equal to, we have got root 2 times of this one. So RS is equal to RB by root. So now coming to this one, next third question. A plank of mass 12 kgs is supported by the two identical springs. The plank always remains horizontal. That means, okay, fine, it's going to be maintained. When the plank is pressed down and released, it performs an SHM with a time period of 3 seconds. Given that time period is equal to 3 seconds. Now, when a mass M is attached on the plank, time period has been become 6 seconds. So initially, I'm taking it as a T1. Now T2 is equal to 6 seconds. So in this case, so two identical springs, let me consider the spring constant to be the K. So obviously these springs are in parallel. So K effective can be written as an K1 plus K2 and both of them are the same. So final answer should be the 2K. Now it's a spring system, sir. Since it's a spring system, time period of a loaded spring is going to be the 2 pi into root over this is m by k, and we don't need actually the k value, but it is 2k. Since mass is changing from this relation, I can say that time period is directly proportional to the square root of mass. So from here, I can write T1 by T2 is equal to root over initial mass is going to be how much? 12 kgs by it is 12 by now an extra mass is added to the 12 and the time period values 3 by 6 is equal to root over 12 by 12 plus m squaring it on either sides cancelling. So this is 1 by 4 is equal to 12 by 12 plus m. Now cross multiply them please. 12 plus m is equal to 48 or from this one m is equal to 36 kgs. So this is our information. It's an SHM conditions. So it is also single answer 36 kgs, please. Next one. If the tension in the stretch in a stretched string fixed at both ends is changed by 21%. Okay, so they are changing the tension by 21%. The fundamental frequency is found to increase by 15 hertz. Then he is asking what are the original frequencies and all these things. Okay, so let me take the tension T1 is equal to T, and the tension T2 can be written as n. It is increased by 121%. That is 120 by 121 by 100 of T. So this is your increased value of the tension. Next, so in this case, the fundamental frequency is yes. So what is the basic formula of the fundamental frequency is? It will be the 1 by 2L into root over tension by linear density mu. So now that this same frequency or F2, if F1 is equal to F, then F2 is equal to F plus 15. So now from the basic formula of the fundamental frequency, we can say that is F is equal to 1 by 2L into 2L into root over tension by linear density. So that means frequency is proportional to the square root of the tension. This is your transverse first law. So from this relation, we can say that F1 by F2 is equal to root over T1 by T2. Now substitute the corresponding values. F by F plus 15. It's been added over there. Now initial tension is, if I write it as a T, T2 is 121 by 100 of initial value. So TT goes off and this will be written as an 100 by 121 if I take it out of the root, that particular thing. So F by F plus 15 can be written as it is 10 by 11. Cross multiply. 11F is equal to 10F plus 150. So from this one, fundamental frequency is equal to 150 Hertz. We have got it. So that means our first option is true. Next one, he is asking velocity of the propagation is going to be changing by how much? So coming to the second question, so from this one, velocity V is equal to root over tension by linear density. So from this one, V1 by V2 is equal to same thing, root over tension T1 by T2. So from this one, velocity is V, V2 we need to find it out. Tension T1 is T and this is 121 by 100 of T. Remove them and go for the cross multiplication. So then it would be the 10V2 should be equal to the 11V, or from this one V2 is equal to 1.1 times of the V. Implies velocity increases by 10%. So this is the increase in the velocity. That means it comes out to be the option C. Fundamental wavelength of the string does not change. Okay. So this remains. This is also true thing. So frequency or the wavelength will not change. So these are the three correct options, please. Frequency is changing, correspondingly velocity is changing, maintaining the lambda to be constant. So now next question, question number 5. Velocity of the sound in the air has been given by the 320. And since it's a closed pipe, the pipe is a closed one end, and the length of the pipe is going to be the L is equal to 1 meter here. So neglecting the corrections and all these things, air column in the pipe, the resonance of the sound frequency. Resonance means, so wherever he is going to get the antinode, we need to find out the antinode location. So in a closed pipe, where do we get the antinode? So first antinode or the first resonance you'll be obtaining. Suppose the water is filled up to this particular level in a resonance tube. Up to this particular thing, if it is being filled with the water, then if the node forms at the edge of the water and antinode forms at the end of the pipe, then you will be getting the first resonance, and this distance is lambda by 4. Okay, so we need to find out the first resonance. According to the formula of this one, frequency of the oscillation F is equal to V by 4L, or if I go for the general formula, NV by 4L, where N is equal to, they'll be in the ratio of 1 comma 3 comma 5, so on. So if I take this as an L1, this is your first resonance. First resonance. Now in the second resonance stage, second resonance, one complete loop will be formed under antinodes. For example, it will be like this. Suppose the water is filled up to some extent like this. So from here, so one complete loop is been formed here. So up to this particular thing. So now this is from here to here. It is lambda by 4. From this region to this region, it is lambda by 2. So your second resonance will occur for a length of lambda by 4 plus lambda by 2. That comes out to be the 3 lambda by 4. Or L2 can be written as an 3 times of the L1. So similarly, so next resonance, that is the third resonance. Third resonance, which is equal to the 5 times, which is 5 times of L. So like this, we need to find out the cases. So for them, I'm going to find out the first resonating length, first resonance where I'm getting to occur frequency. That will be the V by 4L. So from the question, velocity has been given as a 320, length is 1 meter. Velocity is 320 by 4 into length is 1 meter. So 320 by 4, it is 80 hertz, and this is called as an fundamental frequency. And from this one, F2, that is this is called as a second frequency or second resonance. I'm mentioning this is 3 times of F, which is 3 into 80, which is equal to the 240 hertz. So this is the condition, sir. This is called as an harmonic, and this is called as an third harmonic. 3 times you are multiplying, or the same thing is called as an first overtone. This is also called as this. Now coming to the next resonance. So you are going to get the third resonance or third resonance. This is your second resonance, and this is your first resonance. So F3 should be, or this is 5 times of the F, which is 5 into 80. So it should be the 400 hertz, and this is called as an fifth harmonic, or the same thing is also called as an second overtone. Okay, so these are your options, sir. So what can be the 80 is possible? Next one, 240 and 400, all of them are the possible. So your answer should be how much? So that is A, B, D. So your answer is, it's a multiple answer question, A comma B and D. So this is the case. Next one. Coming to the question number 6, a long capillary tube of radius he has given. Radius R is equal to 0.2 mm. Is placed vertically in a beaker, and he has given the surface tension to be the 7.2 into 10 to the power of minus 2 Newton per meter, and angle of contact, that is theta, is equal to 0 degrees. Now he is asking what's the determine the H is equal to how much? The surface tension from capillary rise method is HR rho G by 2 cos theta. This is from capillary rise method. So in this case, HR rho G by, this is the case. So now, so since it is the capillary rise method condition, T is equal to HR rho G. From this one, we need to find out the H is equal to how much? H is equal to 2T cos theta by R rho G. Now let us substitute the values 2 into. Surface tension is 7.2 into 10 to the power of minus 2. 7.2. 7.2 into 10 to the power of minus 2. This is cos 0 degrees by radius. So what's the value of the radius has been given? 0.2 mm. So since it's a 0.2 mm, that is 0.2 into 10 power minus 3, or 2 into 10 to the power of minus 4 into density of the water in SI system 10 cube into G value is 10. Now let us substitute all the values here, so please. So this will goes off. Cos 0 is 1. So this thing denominator will be removed. So leftover value is 7.2 into 10 to the power of minus 2 meters he has given, or the same thing can be written as in 72 centimeters or 7.2 centimeters. Okay, nearby answer he has asked. So it should be the 7 centimeters. So that should be the option C. Next, it's a continuation question, it's a paragraph question. In the first part, we have gone this one, so it is radius is equal to 0.2 mm. And now, if the tube is poured, the tube is now pushed into the water so that only 5 centimeters of the length above the surface, that means H is equal to 5 centimeters. Now he is asking the angle of contact is going to be how much? So to find the angle of contact, we do go for the same sort of a thing. T is equal to H R rho G by 2 cos theta. From this one, cos theta can be written as an H R rho G by 2T. Now substitute all the values, please. So that is cos theta is equal to height raised is 5 centimeters. Centimeters conversion into 10 to the power of minus 2 meters. Radius 2 into 10 to the power of minus 4. Density 10 cube. G value, if I go for the 10, then it is equal to 2 into some 7 into 10 to the power of 7.2. I'm writing it as a 7. Anyway, he's rounding off the things, please. 7 into 10 to the power of surface tension. Where it is 10 to the power of minus 3. It is given in the first part of this one here. So now if I substitute all these values, this is minus 2, I suppose. Okay. Now these two things will go off here. 2 will be can be removed. So cos theta, this 10 power 4, and this will be left over. This is 5 by 7. So since cos theta is equal to 5 by 7, theta is equal to cos inverse of 5 by 7. This is our information. So cos inverse of 5 by 7, option B. Now coming to the next question, this is a very, very important model question. So there is a length B, 90 centimeters is there. It's a turning point above its end. Okay, he has given length is equal to, that is B is equal to 90 centimeters, and specific gravity. Specific gravity is equal to 5 by 9, which implies density of the substance by density of the water is equal to 5 by 9. From this one, density of the substance is equal to 5 by 9 of density of the water. Rho S means density of substance, and rho W, density of water. So now to solve this one, find the length inverse. I'll just redraw the diagram over here. So from here, it has been suspended, the rod is being suspended. The total length is going to be the B. Here at the center, actually, the weight of the rod will be acting in the downward direction, and that will be your mg. Suppose this is the level up to which the water is there, and this is the length where it is being inside the liquid, and this is making an angle theta with the vertical like this. So the buoyancy force will be acting. This point is called as an Let me name it as an CB. CB means center of buoyancy. It is the center of buoyancy, so buoyancy force will be acting into this one. Since he is asked to find the length which is immersed in the liquid, from this point to suppose, let me take this is A, and this point as a B, and this point as a C. So CB is the length inside water. So it is inside the water by that particular length CB. Let us name it as some x. And the total length, that is AB, is equal to B. He has provided this information. So since it is in equilibrium, that is rotational. So clockwise torque should be balanced by the anti-clockwise torque. So for the mg, this should be the perpendicular distance. Let this is O. So perpendicular distance, it should be in this direction. So torque is in clockwise. So clockwise torque is equal to mg into b by 2 into sine theta. So this is the first case, please. And anti-clockwise is equal to, it will be acting at center of buoyancy. So now what will be this distance, perpendicular distance? So it's also opposite side. Okay, so anti-clockwise thing, this is going to be the buoyancy force into B by 2. So this is your perpendicular distance from the A to this particular point. Let me write it as an O dash. So I need the AO dash, perpendicular distance. AO dash is nothing but this distance we have named it as an X. Since it is at the midpoint, so this distance will be written as an X by 2. So that will be the B minus. So this is B minus X by 2. So this is the one we have known. And since in the equilibrium, torque in the clock is equal to torque in the anti-clockwise. So from that information, we can write it as an mg into b by 2 into sine theta is equal to buoyancy force, volume inside into density of the water into g into. So this will be the b minus x by 2. Sorry, sine theta, it should be sine theta cancel over here. G can also be removed. Mass of this one can be written as n. So how can you write the mass? Volume into density, that is volume B into A. Density of the substance is 5 by 9 times of density of the water. Since 5 by 9 times the density of the water, next case, into this will be the B by 2 is equal to. Now when I go for the volume inside, the area into some length x. So this is the one we have just been named it as an x. Next one, density of the water into B minus x by 2. Density of the water removed here. Area can also be removed. So from this one, we can say that if I remove the area also, so finally it will be the 5b square by 18 is equal to 2bx minus x square by 2 goes for 9 times. Now quadratic expression will be there. So what is the quadratic expression is 5b square minus 2bx minus minus x square. So, or else if I reverse this also, no props, this is equal to x square. So from this one, I'll just write here continuation. So here continuation it is. So what are the things that we need to give? So 5b square, we have got it as an or else x square minus 2bx plus 5b square is equal to 0. Is equal to 0 there. So from this one on solving, 3x minus b into 3x minus 5b is equal to 0. On solving this one, we can get x is equal to b by 3, which is equal to the 30 centimeters. This should be your answer. So the answer is 30 centimeters. Next one, sir. The plane progressive wave is being given and x value is equal to 40 centimeters. So 40 centimeters cos of 50 pi t 0.02 pi y. Okay, where y is in centimeters, t is in seconds. He is asking the particle velocity when y is equal to this much and time is equal to this much. What is the general equation? X is equal to a cos of omega t minus kx or ky. Sorry, if it is a kx, it will be a longitudinal wave. Now, when I substitute the values, so x is equal to this is 40 into cos of omega 50 pi t minus 0.02 pi y. So now from this one, particle velocity is what do you mean by particle velocity here? That is the Vp. V of the particle is equal to dx by dt. So dx by dt will be equal to the 40 into 50 pi into sine of 50 pi t minus 0.02 pi y. So we have given this information. Now substitute at x is equal to 25 meters and y is equal to, what is the value of the y here? Sorry, t value, x is equal to this much and the time t is equal to 1 by 100. Substitute in this one, velocity of the particle will be equal to the, now when I go for this one, this will be the, how much sir? Minus of, this is 2000 pi into sine of 50 pi into 1 by 200 minus 0.02 pi into 25. So this value is equal to 10 pi root 2 meters. This is the velocity of the particle that has been at that instant. 10 pi root 2. Next one. A loudspeaker has a diaphragm of 0.2 meters in diameter. This much frequency it is been occurring. F is equal to 1 kilohertz means 1000 hertz. With amplitude of A is equal to, he has mentioned it as an. So directly I'm writing 10 to the power of 5 meters, assuming the vicinity of the same vibration. Density of the air is equal to 1.29 kg per meter cube. Next, velocity of the sound is equal to 340. What's your first question, sir? Pressure amplitude immediately after this one. So first, what is the pressure amplitude? Pressure amplitude. So what do you mean by this pressure amplitude P naught? The formula of the P naught can be written as a rho omega AV. So what is the density over there? It is going to be, he has given it as a density of the air only, that is 1.29. So 1.29 into omega we need. So omega value will be the 2 pi into 10 to the power of 3. Sorry. So omega we need to substitute here 10 to the power of 3 whole square into velocity will be 340 into velocity will be 340, sir. And the last one, velocity I have written, density I have written, omega left over is amplitude. What is an amplitude given? 0.01 into 10 power minus 3 or directly 10 to the power of minus 1. Now multiply these two things every case, please. This is 1.29 into 2 pi into 10 to the power of 5. Sorry, 4 pi square. I can take the pi square also as a 10 into 340 into 10 to the power of minus 5. So it will be remove these two things, please. 4 pi square, you can take it as a 10. So this will be the 1.29 into 40 into, that is the 340. So when I multiplied, almost you should be getting it as a somewhere around 27.55 pressure since Newton meter square. So initial pressure P naught is been matched with this one. So that means first one has to be related to the C. So one C options B and D. So these two options are the wrong. Next we'll go for a next question. Sound intensity of the diaphragm. What is the formula for the sound intensity? B I am going. Sound intensity is equal to, formula is half rho omega square a square into velocity. That comes out to be the half into 1.29 into 10 to the power of how much this one, sir? Density 1.29 only into omega square. Omega square in the sense 2 pi into 10 cube whole square. Amplitude 10 to the power of minus 5 whole square into velocity should be 340. So what will be the values of these things, please? Extra, these are coming to be the squaring here. Okay, so then we need to go for the calculation part. Just a moment. This is going to be the 0.69 is there. 4, 5, we can go for this. And this is 340, and this is going to be the squaring. Okay, 0.645 into, it is 4 pi square into 10 to the power of 6 into 10 to the power of minus 10 into, this is 340. Now pi square 1040 you can write into 340. This is 10 power minus 4 will be left over. So you should be getting the value less than 1. The only value less than 1 is 0.865. So I'm going for this one 0.865. Sound intensity, that will be the watt per meter square. So now that means sound intensity 2 should be related to D. So when 2 is related to D, 1C, 2D, this is the only option that is going to be the present. Or if you want to find the remaining things, that is acoustic power radiated and all these things. So power radiated can be written as N. So take this one, option C, I'm writing the formula. So power radiated. So power radiated is equal to intensity into area. So next one, option D, you can go for. So this is the option D, sir. Like the intensity at 10 meter per intensity formula is I is equal to power by 4 pi small r square. So we need to substitute all the values. By saying the first and second, we can confirm that this is an option B. Fine.